So Professor Simmons here. I'm going to show you how to do in this video the analysis in Excel of your free-fall data, as well as show you how to do the regression analysis in Excel. And this is the intention of this is to be sort of a reference. You'll need to be able to do regression analysis for other labs, so you can refer back to this video is kind of the idea. So let me pull up Excel here. All right, so here's your free-fall data after you've sort of entered it into Excel. So I'll kind of show you what I've done here. So I counted up from when the marks are close together to when they get farther apart in millimeters. And really we want to display this as height off of the floor. So in order to make this into a height, what you have to do is take your initial height. So for me, it looked like this was 1,783 millimeters off the floor. And if I subtract off my initial measurements, or all my measurements from that number, that'll make it those measurements as a reference from the initial height. So that's what this second column is doing. And then the next column here I've divided by 1,000 because I want my measurements to be in meters rather than in millimeters. We're interested in G, and we usually specify that in meters per second squared. So I'm just going to go ahead and convert this into meters. All right. So now we have our data here. Let's plot it. It's kind of a theme, but plots are a much better way to convey information than in just a list of numbers. So we're going to do that. Now, before I do that, kind of to make Excel happy, and you'll find, I think, working with Excel, that it has a lot of quirks. But I'm just going to put the time and height measurements that we want to plot in adjacent columns. And then I'm going to select those columns and insert a scatter plot. So you'll notice this creates an XY scatter plot. You'll notice this doesn't have any labels. That's not very good. So let's add some titles to our axes. This is essential to making a plot that your reader can understand. So this is a plot of the height in meters as a function of time. So this is cool. We can add to this a trend line. Now, that linear trend line is no good. That's not what we want. So we need to select here more options. We know that this, or you'll know at this point, that this is a quadratic function. In other words, it's a polynomial of order 2. So we can have Excel stick a polynomial fit onto there. And I'm just going to delete this linear trend line. And you can see, or you'll know that this corresponds to our y equals y naught plus v naught t plus 1/2 at squared. And the thing that we're interested in, the piece that we're interested in, is this 1/2 a. And we know for this that should be g, and this is quite close to g. Your numbers will be a little bit different because you're using your own experimental data, but that gives you kind of the big picture in terms of fitting that quadratic expression that you're familiar with to your experimental free-fall data. Now, what else can we do here? Another thing that we want to do is to create velocity as well. So how do we create velocity? Well, we can do that by numerical differentiation is actually what we're doing. We're going to look at the rise over the run, the slope of that height per time. So to do that, we're going to take and subtract, i.e. find the change in height over the change in time. And we're going to use the points on either side to generate one velocity point. And then what we can do is you can just click on the corner of this, double click on it, and it'll fill all the way down. So it's applying, if you select any one of these, you can see it's making use of the surrounding height and time points. Now, there's one glitch with this. Notice this last point is messed up because it's referencing cells that aren't there. So for that one, we need to delete that point. In other words, you have fewer on the ends. You're missing the endpoints, velocity points, than time or height points because of the way the calculation is done. So what we do then is let's plot this as well. A scatter plot, and it looks roughly linear. There's a few little, kinks in here, and that's, those kinks pop out because of the differentiation operation. Just like we did above, we would want to make sure that we have proper labels. Like now this is still time. Now this is velocity. Okay. And we can do the same operation that we did. We can add a trend line, linear trend line, but let's look at the options and have it spit out our equation as well. And we know that for this case, this is v equals v naught plus at. And so the slope of this should give us g, and we can see that it's pretty close. Okay, good. So that's kind of the procedure, how you create the velocity column, as well as you can have it spit out trend line fits for those two figures. Now, we can also do this extraction of these numbers in a more sophisticated way, and that's with regression analysis. So to do that, we can do two different versions of this: linear regression and quadratic regression. So for the linear regression, we're going to look at the time and the velocity. So I duplicate this column again, just so that Excel is happy with us. And here's how you do the regression. So you go to the data tab. Way up in the upper right here, you'll see this data analysis bit. If you don't have this, you need to go to File, Options, Add-ins, and it's this analysis add-in. So you'll have to play around with that to get that added. Okay, so let me show you how this works. So if you click on this data analysis tab, we're going to do regression. And what you do is you select the Y range and the X range. So our Y range is going to be this. Our X range is going to be this. And we're going to have this just output it as a new tab, and then we'll study it in there. So if I click OK, it's generated a new sheet that gives us a little report. Now, most of this report is not relevant to what we are interested in. We are only interested in these entries. So this is the slope, and this is the intercept. This is the uncertainty in the slope, and this is the uncertainty in the intercept. So in other words, this is not 9.9 plus or minus 0.1. The rest of this is not what we're looking at. So when you're using this in class, don't just put this whole report into things. Instead, refer to the part that is of interest to us. The slope and the intercept, and the uncertainty in the slope and the intercept respectively. Okay, so you'll notice this is a linear regression. We can also do the quadratic regression. So quadratic regression requires a column of time squared. I'm going to make that. Made a column of our time squared. Now we do the same thing. You go to the data analysis tab, regression analysis. Now you'll notice now in this case our times, instead of this time column, we're going to use both of these time columns. Or sorry, I have this switched around here. Our height, y, and our x then will be both of these time columns, both x and x squared. And we're going to have it spit out a new tab as well. And again, the only part of this that we're interested in is this bit. So now we have our intercept, uncertainty in the intercept, the linear term, i.e. the V naught term, and its uncertainty, and the squared term, our 4.9, and the uncertainty in that. So notice these numbers match up with what our trend line returned, but the big advantage of the regression analysis over this simple trend line is that this also gives us the standard error. So it's a little more complicated, more numerical method of doing this, but it gives us more information. So it gives us the error in addition to the coefficients. So it's like a lot of things, if you do it in a more complicated or a more sophisticated way, you can get more information. And so this is how you do a linear and quadratic regression in Excel, and you'll likely this will hopefully be of use to you as you do your other labs. There's other labs where you'll need to be able to do this. So